So we're looking at Introduction to Scatterplots. This is our third lesson within our series of bivariate data. So let's get started with this. Here we go. All right, so lesson objectives for today: construct a scatterplot by hand, examine the key elements from a scatterplot, and construct scatterplots using the ClassPad. So some skills involving your ClassPad, so it'd be a good idea to have that out in front of you. All right, pretty straightforward for today. So what we have is scatterplots. Firstly, all of these individual dots are representative of a score. Okay, we've got two variables here, so we're comparing age against height. All right, so we have a scatterplot like so. Obviously, it's bivariate data because we're comparing two variables against each other. And we want to be able to determine whether there is in fact an association between these two variables or not. Now, first thing, what we can see is we've previously done EV and the RV. Whoops, sorry, just go back. Okay, so we've previously looked at the explanatory variable and the response variable. So from here is that we've got our explanatory variable is always going to be along our horizontal axis, and our response variable is always going to be along our vertical axis. So in a question, if it asks you about the explanatory and the response variable, okay, for what identify it, you may in fact be able to look further down the question if there is a graph and simply look along the x-axis or along the horizontal axis to very simply identify the explanatory variable. That's a nice easy way to be able to do it as opposed to thinking about what the explanatory variable may in fact be. All right, everything we're going to be looking at is a linear line. Sometimes it might not represent a linear line, which is a comment that we're going to have to be making a little bit later on. Okay, so for this graph here, we can see it's following a pretty good relationship as a straight line. And then what we might in fact start to see within this language here is that just some of those points is that they are starting to go a little bit further away as you get older. Your height is in fact changing a little bit more. From a younger age, it's following the line pretty closely. As this then tends on to older, obviously what we then know for age is that it then starts to fluctuate quite a bit. So it doesn't really follow that trend anymore. All right. Here is the salaries against age of NBA players, and as you can see, salaries and age are completely different. There's no real relationship here, so as you get older doesn't necessarily mean you will be paid more. You can see there are in fact some quite young people like up here who are actually reasonably well paid in comparison to these people over here who are a fair bit older and not paid as well. Right, here's some examples. So we've got student 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and their results. Once again, because what we've previously done within mathematics is we'd usually have this as our x and y. So what happens is that the x will always correspond to your horizontal axis, which is going to be my explanatory variable. So once again, this is quite a good way for you to be able to identify your explanatory and your response variable from a table. So we are using time to explain the mark, or time in hours used to explain the mark. Here's a summary of that: the explanatory variable on the horizontal axis and the response variable on the vertical or y-axis. The skill that you need to be able to is plot these. Okay, so the first one has in fact been plotted for you. All right, and as you continue through that, it represents a single data point. Okay. You do not need to label every single student 1, student 2, nor the actual coordinate itself. That would take too long. You simply just need to put the dot or the single data point. Right, you'll need to finish all of the other data points as well. And we'll have a look and see what that looks like here. We can see that what's happening is that as the time is increasing, going to the right, your percentage or your mark is also increasing, and it's tending to follow a bit of a straight line as well. Okay, that's what we're tending to lead to within this unit of work here. Here's our next example. The scatterplot shown constructed from a data collected to investigate the relationship between the price of a second-hand car and its age. So what we can see is as it is getting older, Here is my EV, just to reinforce that, and here is my response variable. As the car is getting older, generally speaking, what we can see is that the dots are going downwards. I didn't draw that perfectly. Which is the explanatory variable and which is the response variable? Pretty self-explanatory. We can see that from the axes themselves. How many cars are there in the data set? Well, what are you going to do? You're going to count all the dots there. So if you count all the dots, you should end up with 12 dots on your scatter graph. How old is the car circled and what is its price? Well, it's pretty self-explanatory. The one circled corresponds down to 6 and corresponds over to 12. Don't forget that 12, the price is in thousands of dollars, so it's actually $12,000. All right, and as we continue through, last one. The data below give the marks of 10 students, as we just had before. Use your calculator to construct a scatter plot. Use time as the explanatory variable as we suggested before. So here's a little, some hints on how to actually construct this on your ClassPad. The skill here isn't that fantastic, not until we start to do the analysis of all of this stuff. So it's not that relevant at this point. However, you can start to see whether your graph looks something like what it should do. Okay. It's important to list the X values or time in this case in list 1 and the mark in list 2. All right, like seen, like so. As you're inputting it, it's really important to check that they correspond to each other going across, okay, like so. Quite often there's input errors, which are obviously going to make it look a little bit funny on the graph, so it's definitely worth checking that. I push EXE after every number, which takes me down to the next one, so I find that quite helpful, but it's up to you. Okay, got to change the settings. Yours should default to scatter, but just in case it doesn't, just go through and check those. All right, so clicking on that graph at the top, make sure it's set on scatter, list 1, list 2, etc. And then click on the top left for graph, and it should construct your scatter graph. That's what it should look like. If you want to make it full screen, you can. And then if you click on the XY pointing outwards, you can actually look at each individual data point. And then by moving left and right, it will be able to show you all the data points or each individual data point. That could be handy if you had like an outlier and you wanted to know the exact data point of that one. That would be a pretty good idea for that. Okay. All right. And that's how it should look like in the end. Perfect. All right, that is it. You can get started on that lesson 3.